Hi guys. So today's lesson is more on angles. It's on angle relationships, or sometimes I refer to as angle pairs, because it's all about different types of angles that come in pairs, come in two, and what their relationship is. So that's our lesson for today. So let's get started. Okay, so this first one is called adjacent angles. And adjacent angles, well, let's think about what the word adjacent means, just like in life. Adjacent means next to. So, like if you had two rooms that were adjacent, they share a wall. So, two angles that are adjacent share a side. So, if you take a look at this picture here, this angle ABC and this angle CBD would be considered adjacent because they share this vertex and they share this side. So angle ABC and angle CBD, those would be adjacent. Their measures don't have any sort of relationship, just that the two small ones add together to equal the big one. So that's it for adjacent. Vertical angles are next. Vertical angles are a type of angles that we use all throughout the year. You'll see that vertical angles keep popping up and popping up and popping up. So they'll end up being like really easy after a while. Basically, vertical angles are opposite each other. They share a vertex, but no sides. So like this one and this one would be vertical, and then this one and this one would be vertical. Vertical angles are always congruent. That's why I marked them in the way I just did to show that they're congruent. No matter what, their measures are always equal. So if we wanted to list the vertical angles here, we could say angle DAC and angle BAE. And then we could say angle DAB and angle CAE. So those would be vertical angles. Next is complementary and supplementary. So first, complementary are angles whose measures add to 90. So they have a sum of 90 degrees. Each angle is called the complement of the other. So this 55-degree angle and this 35-degree angle, those are complements of each other because they add to 90. Notice that those aren't next to each other. They're not adjacent. Complementary angles don't have to be adjacent, but they can be. Oftentimes, this is what complementary angles look like. You'll be given this picture and they'll tell you that this is 90, and then you know that those two add to 90. So that's complementary angles. Next is supplementary angles. Supplementary angles are two angles whose measures add to 180. Again, they can be next to each other like this one, or they don't have to be next to each other either. So either way works. They add to 180, and each angle is called the supplement of the other. So 70 is the supplement of 110. Next is a linear pair. So supplementary angles and linear pairs kind of go together. And what I mean by go together is linear pairs are always going to be supplementary. So they're just like a more specific type of supplementary angles. Linear pairs, this is a linear pair. It's supplementary angles that are basically next to each other. So here's our linear pair. They make a straight line. They add to 180. They are adjacent. They share this common side and this common vertex. So linear pairs are always supplementary, but not all supplementary angles are linear pairs. So if you look at these two, those are not a linear pair because they're not touching. So you'll see as we go through most of what we deal with supplementary angles, most of them are linear pairs. Okay, so I just figured we could go through some examples. We're going to use this picture to name some different types of angles. So the first one wants two acute vertical angles. Remember that acute is less than 90 and vertical are the type that are opposite each other. So it would actually be EKH, this one here, and FKG, this one here. Those would be acute, less than 90, vertical angles. They're opposite each other and they share a vertex. So angle EKH and angle FKG. Those would be acute vertical angles. Okay. Next, two obtuse vertical angles. So if those two were acute vertical angles, this one and this one would be obtuse vertical angles, bigger than 90 and vertical, opposite each other. So that's going to be angle EKF. That's this top one here. And angle HKG. Remember that when you're naming angles, you use 3 letters, all capitals, and the middle letter is the vertex. Other than that, the order doesn't really matter, just as long as the vertex is in the middle. Name a linear pair. So in order to name a linear pair, we need a line. So let's use this line. Now we need two angles that together make that line. So see these two, or I could have done the other side also, it doesn't matter. But this side is a little cleaner because there's only two angles on it. So this one here, EKH, and this one here, EKF. Those would be considered a linear pair. Okay, next is two acute adjacent angles. So two angles that are less than 90 that are next to each other. Whoops. So I see, let's see, we could use this one here and this one here. Those are two acute adjacent angles. So we have angle FKG and angle JKG. Those are acute adjacent angles. Okay. Next, an angle complementary to angle EKH. So let's go back to this picture. Complementary to EKH. So EKH is here. Complementary means add to this one to make 90. So this one's kind of tricky because there actually is no answer here. Nothing in this picture is complementary to EKH. Well, let's say we can't be certain that anything in this picture is complementary to EKH because they didn't tell us the measure of EKH. They didn't tell us the measure of any of the angles. They also didn't say that any of them were 90 because sometimes like that you can kind of tell if you know one of them's 90, but we weren't told anything about this picture. So there's not enough information to answer this one. So I'm going to say none for number 5. Next one, an angle supplementary to FKG. So let's go back to the picture. Whoops, try to erase. FKG is this one. This one we can name one because we do know that, say, like these two angles, for example, would add to 180 because those two angles are a linear pair, which also makes them supplementary. So this was asking for an angle that was supplementary to FKG. That's this one. So this one would be the answer. Angle EKF. Another possible answer, in case anyone's wondering is this one would also work because it would make a linear pair this way. So either way. So it's EKF for number 6. Okay. And the last one says angle EKH is 78 degrees. Find FKG and EKF. So let me erase this. Go back here again. So it says, I'll zoom out, EKH is 78. So EKH, this one here is 78. And it wants us to find this one and this one. So we have to ask ourselves, what's the relationship between these angles? EKH and FKG are vertical, which means they're equal. So FKG is 78 degrees. Then these two, EKH and EKF, these are a linear pair. So if we do 180 minus 78, that would tell us the measure of EKF, which is 102. So this one is 102. Whoops, not 120. What am I doing? 102. Okay. So FKG is 78 because they're vertical. EKF is 102 because they're a linear pair. Okay, so that's that first little example with just naming the different figures. The last 3 examples are with algebra. So just like what we've been doing with the other angle practice and the segment practice that we did, when you have algebra in a math problem and in a geometry problem, you want to use the geometry that you know to figure out an equation to set up. So if you look at this picture here, let me zoom in a little bit more. It says PQT is 3x plus 47. So let's start with labeling PQT with 3x plus 47. And then SQR is 6x minus 25. It's asking us to find the measure of SQR. So really, we also have to find x and measure of SQR. So before we set anything up, we have to think about, what do we know about these two angles? Are they supplementary? Are they complementary? Are they vertical? What do we know about them? Hopefully you recognize that these are vertical angles, which then we have to think about, okay, well, what do we know about vertical angles? Vertical angles are always equal. So that means we're just going to set these equal to each other. We're going to have 3x plus 47 equals 6x minus 25. Okay, so then you just solve for x. So I'm going to subtract 3x from both sides. I'm going to have 47 equals 3x minus 25. I'm going to add 25 to both sides. So that's 72 equals 3x, and then divide by 3, x is 24. Okay, and then it also said to find the measure of SQR. So SQR is 6x minus 25. So let's see, where can I fit that in? I'll do it right over here. I'll squeeze it in here. So the measure of angle SQR is going to be 6 times 24 and then minus 25. So 6 times 24 is 144, and then minus 25 is going to be 119. So that means that SQR is 119 degrees. So this is 119, and then if we ask for this one, also 119. So we have to label the picture, figure out what type of angles they are, think about what we know about them, set up your equation, solve for x, and then sometimes plug in. Here's another one. DCB is a right angle. Oh no, this got cut off. Okay, well, we'll say this is DCB. DCB is a right angle. DCE is equal to 7x plus 2. ECB is x plus 8. Find the measure of DCE. So first we have to find x again. We have to think about what kind of angles are they. Notice that these two angles together make this 90-degree angle, so these are complementary angles, which means they add to 90. So what we're going to do is we're going to set up an equation. This plus this equals 90. So we're going to have 7x plus 2 plus x plus 8 equals 90. When you have all of this on the left-hand side or on either side of an equation, you first want to combine like terms. So 7x and x is going to be 8x. 2 and 8 is going to be 10. Subtract 10, so 8x equals 80. X equals 10. Divide by 8. Not only did it ask for x, it also asked for the measure of angle DCE. So DCE, I'll fill it in right here. DCE is this one, 7x plus 2. So you're going to do 7 times 10 plus 2. So 70 plus 2 is 72 degrees. So that's the measure of angle DCE. So I wrote the equation, I add them to 90 because they're complementary, and then solve for x and plugged in. The last example that we're going to do, you're asked to just find x and y. So if you look at this picture, notice that there's 3 angles given, and some of them have x's and one of them has a y. So notice like these two are vertical, these two are a linear pair, these two are a linear pair. So there's a few options here. Well, really there's actually, I take that back. There's only really one option because yes, these are vertical and they're equal to each other, but one has an x and one has a y. So you don't want to write an equation where one has an x and one has a y in it because you can't solve it. You'd have to do what's called write a system of equations. Also too, these two, yes, those add to 180, but again, one has a y and one has an x, and so you don't want to use those two together. So really your only option here is to use these two because they both have an x in it. So those are a linear pair. And so we're going to add them to 180 and solve. So we're just going to take 10x minus 61 plus x plus 10 and set it equal to 180. Because they're a linear pair, which means they're supplementary, which means they add to 180. Then we combine like terms. We have 10x and x is 11x. Negative 61 and 10 is negative 51. And we're going to add 51 to both sides. So this is 231 equals 11x. And then lastly, divide 231 by 11, which is 21. Okay, so now that we know x is 21, we can use that to help us find y. And so what we're going to do is we're going to take 21, we're going to plug it into either one of these expressions. So like, see how this one is x plus 10? So now I can do 21 plus 10. 21 plus 10 is 31. So this one's 31, making these two 149, because I can just subtract 31 from 180. So now to find y, I can do a few different things. I could do 18y plus 5 plus 31 equals 180. Or I just found that it's equal to 149. So I can just do 18y plus 5 equals 149 and solve. So I'm going to subtract 5. So that's 18y equals 144. And now we just need to do 144 divided by 18, which is 8. So y is 8. And then we're all done. So x is 21 and y is 8. So again, with something like this, you want to look at the angles that have the same variable, set something up with those, and then take that, plug it in to help find the other one. So that's that for angle pairs. We have complementary adds to 90, supplementary adds to 180, linear pair also adds to 180. They're next to each other, make a straight line, vertical or equal. And so that's that for angle pairs. Let me know if you have any questions tomorrow when I see you in class. We can go over more of these, and I can answer any questions you may have. All right, have a great day.